Hey y'all, it's Julie the nursing tutor. I've got some drops per minute and microgram per kilogram per minute problems that I wanted to work right quick for your enjoyment and your pleasure. Here you go. So, a client who is scheduled for a kidney transplant received a prescription for that medicine right there. We're not here to pronounce words, we're here to do math. 20 milligrams IV 2 hours prior to surgery. The medication is available in a 20 milligram vial that is reconstituted by adding 5 milliliters of sterile water for injection and administered in a 50 milliliter bag of normal saline over 30 minutes. The nurse should program the infusion pump to how many milliliters an hour? All right. So he wants them to get 20 milligrams. The vial is 20 milligrams. So we're going to add 5 milliliters in it, pull the 5 milliliters out, and we have to inject that 5 milliliters in a 50 milliliter bag, which will make, if it's 50 milliliters and we added 50 milliliters, it's going to make the total volume 55 milliliters. And they're wanting us to find milliliters an hour. So the formula for milliliters per hour is the total volume divided by the time in hours. Okay? So the total volume that we have is going to be this 55. You got to remember to add the 5 to the 50 and have 55 total volume. Okay. And then how long is it going in? 30 minutes. But to do milliliters an hour, it needs to be in hours. So when you find yourself in this situation, and the infusion time for a milliliter per hour problem is less than 60 minutes or less than an hour, if you will just add 60 to the top and multiply the total volume times 60 and then divide it by 30, you're telling the problem that we're dealing with a 60-minute hour. Otherwise, the problem's going to think it's a 30-minute hour. Now, there's some people on TikTok that'll say, well, you could use 0.5 and not use that 60, and that's true. My problem comes in when it's 20 minutes or 15 or 45 or 50. I don't want to have another calculation that I have to do and get correct to put it in this when I could just tell the problem it's a 60-minute hour. All right, I'm off my soapbox. So we're going to do that times that divided by that. Watch here. 55 times 60 equals divided by 30. So we'd set it at 110 milliliters per hour. Look, boom. Sure enough did save another one. You know we did. All right, look at this one. The healthcare provider prescribes a continuous infusion of 5% dextrose and half normal saline at 85 milliliters an hour. The IV administration set delivers 10 drops per milliliter. That's my hair. Sorry. The nurse should regulate the drop rate to deliver how many drops a minute. So it's going at 85 milliliters an hour. So this is what we can use as for our problem. The total volume would be 85 milliliters. And it's drop factor because they mentioned the tubing and told us it's a 10 drop factor. And it's going in over an hour. And for drops per minute, it's got to be in minutes, so it'll be 60 minutes. And then here we go, like Olympic gold medalists with our handy-dandy calculator. 85 times 10 equals divided by 60. You see that's going to be 14.16 that 6 will make that a 2, but that's all it's going to do. And so the answer will be 14 drops per minute, because you can't give 0.16 of a drop. Look, but you can give 14 drops a minute and save another one. Look, I hope y'all enjoying it. Okay. And then it says a client returns to the nursing unit from surgery with a prescription for lactated ringer solution, 1,000 milliliters, to be infused over 10 hours. The IV administration set delivers 60 drops per minute. The nurse should set her calculation rate. And so drops per minute, the total volume is 1,000 milliliters times 60 drop factor divided by the time in minutes. It's got to go over 10 hours. So if we multiply 10 times 60, that's going to be 600 minutes. And we can do the math. This times that divided by that. 100 times 60 equals, divided by 600 equals. It needs to go in over 10 at 10 drops per minute. Now, I know there's people on here that's just chomping at the dad blame bit. Look, boom. Sure enough did save another one. Because when you have 1,000 milliliters to go in over 10 hours, you can divide 1,000 by 10, 1,000 divided by 10, and it would need to be 100 milliliters to go in over 1 hour. Now, some of y'all that did a Jedi mind trick on. Others it didn't, but if you, because some people, it'll panic them if they got to do a whole nother calculation. So if you understand this, then do this every time. I'm just doing this so there won't be a whole bunch of comments telling me I could have done this and that. I know, but I'm trying to lay a firm foundation. Anyway, so here we go. Normal saline with that medicine right there, 0.1 grams in 100 milliliters is prescribed for a client with heart failure. The medication is to be delivered at a rate of 400 micrograms per minute. The nurse should program the infusion pump to deliver how many milliliters an hour? Okay. So he wants it at 400 micrograms per minute. But Ethel wants my answer to be in an hour. So if I multiply 400 micrograms times 60, I can find out how many micrograms they want per minute. 400 times 60, 24,000 micrograms per hour is what that will be. And what we have on hand is 0.1 grams. I'm gonna just pull this right here. So, you know, kilogram, gram, milligram, microgram. Sorry. Milligram, microgram. And if we're going from grams to milligrams, this tells us we're going to move our decimal to the right. So it said we had 0.1 grams. I'm going to grab it. This tells you move it to the right. You have to know to move it 3 places. So it's 1, 2, 3. it would be 100 milligrams. Per 100 milliliters. Now back over here, after when we found out how many micrograms per hour, I'm going to convert these micrograms to milligrams, because now I know that what I have on hand is 100 milligrams per 100 milliliters. And if I've got 2,400 micrograms, and I'm going from micrograms to milligrams, I'm moving my decimal place to the left. I have to know it's 3 places. So it's understood to be behind the whole number. And I'm going to go 1, 2, 3. And so that would equal 24 milligrams would be what the man wants, Mr. Man. What I have is this 100 milligrams per 100 milliliters. Help them, Lord. I hope I ain't just done a Jedi mind trick on you. And then we're doing the math. 24 divided by 100 times 100 with our calculator. Divided by 100 equals times 100 equals. I know it. You could have marked it out, but there's other people who don't realize all that. So it'd be 24 milliliters per hour. Look, boom. Yeah, it is. When they give you so many milligrams or micrograms or whatever units per minute, I don't want you to throw up in your mouth. Take a swallow of a beverage and realize that you have the power to multiply that sucker times 60 to find out what you got to give in an hour. Okay? I believe you're picking up what I'm putting down. So, let's do this one. A client with all that is receiving an infusion of 5% dextrose with Amacan 0.572 grams in 100 milliliters every 12 hours. The nurse prepares the dose using a vial labeled 250 milligrams per milliliter. How many milliliters should she give should she add to the infusion? So he wants 0.572. I'm fixing to convert that. kg, mg, mcg. And we're going from grams to milligrams, so I'm moving it that way. 1, 2, 3. So 572 milligrams per 100 milliliters every 8 hours. The nurse prepares the dose from a vial of 250 milligrams per milliliter. So what he wants, because we have to add this medicine to this 100 milliliter bag, what he wants is 572 milligrams. What I have in my hand in this vial is 250 milligrams per 1 ml. Yeah, Ethel was sipping that stuff writing this. So we're going to do this divided by that times that. 572 divided by 250 equals times 1 milliliter. We would still have to draw out, if rounding is required, you round it to the nearest tenth. So it's 2, and you see that 8 is going to make that 2 a 3. So you would pull out 2.3 milliliters of medicine and add it to this 100 milliliter bag. And so it's going to be 102.3 milliliters is our total volume. But is that all he wanted? Oh, look, that's all they wanted. 2.3 milliliters. Because the question we were answering was, after this sucker quits having a seizure, how many milliliters should she add to the infusion? 2.3. Saved them. Okay. I know I read all over this. So a client has a mitral valve replacement surgery, receives a prescription for dextrose and water, 0.5 grams of dobutamine in 250 milliliters of IV for IV infusion at a rate of 5 micrograms per kilogram per minute. The client's weight is 75 kilograms. The nurse should program the infusion pump to deliver how many milliliters an hour? All right. Thankfully, they already put it in kilograms. And so Mr. Man wants them to get 5 micrograms for every kilogram. And we have 75 of them. So the first thing we have to do is multiply 75 kilograms times 5 micrograms. And so we're going to 75 times 5 equals. And that is 375 micrograms. And you see it's per minute. So to find out what we have to do per hour, because we got to do milliliters per hour, you know what we're doing. Multiplying it times 60. Why? Because we can. 375 times 60 equals. And that's 22500 micrograms per hour. Okay. And of course, Ethel done put the dobutamine. We got to convert. So I'm going to convert micrograms to milligrams. And I'm going to move this decimal 1, 2, 3 right here. And so the dose ordered is going to be 22. It said if rounding is required, round to the nearest tenth. So it's going to be 22.5 milligrams. That's the dose ordered. What I have in my hand is 0.5 grams. I'm going to convert that to milligrams. So going from grams to milligrams, you got to move your decimal to the right 3 places. 1, 2, 3. So that would be 500 milligrams and 250 milliliters. So he wants 22.5. What I have is 500 milligrams per 250 milliliters. And then we're going to do the math. This divided by that times this. I know it took a whole page, but you got to make peace with it. Divided by 500 equals times 250 equals 11.25. She said round to the nearest tenths. That 5's going to make that 2 or 3, and that sure enough would be 11.3 milliliters per hour. Look, I done read all over it. Wrote. I know that wrote is correct, but I sure hope you enjoyed it. I don't know what just happened. But look, let me show you my little girl. See? Touch of God. Okay. I just wanted to tell you thank you for watching with my little thing. I hope it helped. Be sure to go to YouTube at the Nursing Tutor 621 and subscribe. Like this video. Share it. Comment. saved another one, or boom, I don't care. But anything you do is going to help TikTok know that you like it. And that's my Facebook page. Y'all have a wonderful evening.